everyone, myself Priya Malu, lecturer in electronics, Government Polytechnic Ausari, welcomes you all on conduction of topic Semi-conductor Diode. After completion of this topic, the learners will be able to define forward bias and reverse bias of diode, implement the forward bias and reverse bias, sketch the VI characteristics of diode, and differentiate between forward bias and reverse bias. As far as the construction and symbol is concerned, a PN junction diode is made up from a P-type material and N-type material, which are chemically combined under a suitable condition so as to form a junction, which is called as PN junction. A P-type material consists of a large number of positive charge called as the holes, and N-type material consists of large number of electrons having the negative charge. These holes and electrons are called as majority carriers in P and N region respectively. Now let us see the symbol of the PN junction diode. It will look like this. A P region acts as anode and the N region will act like a cathode. Now let us go with the forward biasing of diode. Before studying this, we should know what is the meaning of biasing. Applying an external DC voltage to electronic device is called as the biasing. Now, what is the forward biasing? Let us see this circuit diagram. Here, the positive terminal of the battery is connected to anode and negative terminal of the battery is connected to cathode. So, we can say that if the external DC voltage is applied in such a way that P region is connected to the positive terminal of battery and N region is connected to the negative terminal of battery, then these connections are forming a forward bias. After doing this connection, you can see that the large number of holes available in the P region are connected to the positive terminal of battery and large number of electrons available in the N-type material are connected to negative terminal of battery. Now, positive terminal of the battery pushes the holes against this barrier potential and the negative terminal of the battery pushes the free electrons. As these electrons are having the negative charge and terminal of battery is also negative, so there will be the force of repulsion and these electrons will move away from the negative terminal. Same is happening with holes available in P-type material also. Now, due to that, here the width of the depletion region is going to reduce. The depletion region concept we have already studied in our previous session. As the applied voltage is going to increase at a particular stage, the depletion region will become narrow. Majority charge carriers can easily cross the junction. In our case, holes and electrons are the majority charge carriers in P region and N region respectively. A large number of majority charge carriers constitute a current called as the forward current. Current in the P region due to the movement of the holes called as the hole current, and current in the N region due to the movement of the electrons are called as the electron current. Now let us see the forward VI characteristics of the diode. These are the characteristics which are plotted in between the forward voltage and forward current. Now, as we go on increasing the value of VA, the effect on current will be observed like this. This is an exponential graph. So, as long as the VA forward voltage is less than the cutting voltage, in voltage, then current increases rapidly. Now, the cut-in voltage for silicon type of material is 0.7 volt and for germanium type of semiconductor material is 0.3 volt. Now, it is the time to think and reflect. Pause the video and record your answer in a notebook. For the question, how will you define the reverse biasing and what will be the effect of it on depletion region? If you have finished writing, then play the video and see the answer. So, reverse biasing of the diode is nothing but when we connect the negative terminal of the battery to the anode of the diode and positive terminal of the battery is connected to cathode of the diode. We can say that when the external DC voltage is applied in such a way that P region is connected to negative terminal of battery and N region or the cathode is connected to positive terminal of battery, it will be called as the reverse biasing. Now let us see how this working principle will be followed. See here, large number of holes available in P-type. This carries the positive charge. These are connected to the negative terminal of battery. So, this positive and this negative, there will be the force of attraction. So, all these holes will move towards the negative terminal of battery. Similarly, electrons carry negative charge. This battery is having the positive charge. So, all electrons are attracted towards the positive terminal of battery. Due to this, it is going to widen the depletion region and barrier potential is going to increase. No majority charge carriers can cross the junction because this depletion region is made up of the immobile carriers. So, no majority charge carrier can cross the junction. And due to that, the resistance of the reverse bias diode is very high. Due to the increased barrier potential, the free electrons on P side are dragged towards the positive and the holes on the N side are dragged towards the negative terminal of the battery. This constitutes a current called as the reverse current and it flows due to the minority charge carriers. Similarly, see the VI characteristics of the reverse VI characteristics of the diode. Reverse characteristics of the diode is plotted onto the third quadrant. As the values of the voltage and current both are reverted, the minus symbol is applied. Minus notation is applied. Now, let us see. As the reverse voltage increases, the reverse current also increases initially. So, for this duration, if you increase the reverse voltage, your current will also increase, but that is only for a short duration. After an increase in the voltage, the reverse current also remains constant till the point A. Once a point is reached, a reverse breakdown happens and current increases sharply. Voltage corresponding to the point A is called as the reverse breakdown voltage. Now, the question for the student, difference between the forward and reverse biasing. So, here the few parameters are given like definition, circuit diagram, depletion width, current flow and the VI characteristic. Depending on these few parameters, you have to differentiate between the forward bias and reverse bias. So, thank you very much for listening this whole video carefully.